I'm Tyler, and in this lesson, we'll look at the information about compounds and chemical formulas that you need to know for the chemistry section of the TEAS. We'll also talk about the compounds and chemical formulas that you should definitely have memorized for the TEAS. Now, if you're watching this video on YouTube, you're really lucky, and that's because it won't be on YouTube forever. This video is part of my TEAS Chemistry Essentials full course. And I'm putting that course together right now. I'm filming all the videos, I'm finishing everything up, and when I'm done making the course, I'm taking these videos off YouTube. But you'll always be able to find them on my website, teasinOneday.com. So be sure to go there and sign up now so you can get access to the full course on all of these topics when it's ready and when the videos disappear from YouTube. Oh, and lastly, if you have any questions about the TEAS or the science section, if you've got comments, you want to say hi, whatever, email me, Tyler@teasinOneday.com. I really want to help. I look forward to hearing from you and trying to answer all your questions. Okay, let's get started talking about compounds and chemical formulas for the TEAS. Some background review, okay? All the matter, or stuff, in the universe is made of tiny particles called atoms. And there are different types of atoms, and we call these elements. So some examples of elements are copper, sodium, chlorine, oxygen, and hydrogen. Different types of atoms. Now, there are over 100 elements, and they're organized here on the periodic table. Each element lives in its own little square, and it has its own name and its own symbol. You can think of elements kind of like nature's building blocks. And that's because everything in the world around us is made of different combinations of these elements. So I like to think of them sort of, as Legos or building blocks. You got 100 different elements, and nature uses those to build everything in the world around us. Okay, speaking of making stuff, building stuff, let's look at the specific elements that make up these substances that we see right here. Now, sometimes things are made of just one element, like the copper ring here, right? Which is made up of only copper atoms. We zoom in billions and billions of times, and we see that it's only made up of one copper atom after another. But most of the stuff in the world around us is a combination of more than one element. Okay, so like the water, which is a combination of oxygen and hydrogen. Or the salt over here, which is a combination of sodium and chlorine. It's made up of more than one element. So substances that are made of more than one element are called compounds. A compound is a substance that is made of a combination of two or more elements. So water and salt here are both examples of compounds. They're made of more than one element. To learn more about compounds, we're going to look at these 4 common compounds that you see right here. Okay? We got water, we got hydrogen peroxide, natural gas, and sugar. We're going to focus on the atoms and elements that make up these compounds. Here's water, which we've already talked about a little bit. Now, if you zoomed in millions and millions of times, you'd see that water is made of tiny molecules. And here we have some right there. Now, if you looked even closer, you'd see that each water molecule is made up of 2 atoms of hydrogen. These are the white atoms here, attached to 1 atom of oxygen. That's the red atom right here. Now, water is always made of 2 hydrogen atoms attached to 1 oxygen atom. Every drop of water anywhere in the universe is made of molecules with 2 hydrogen atoms attached to 1 oxygen atom. That doesn't ever change. We call this the chemical composition of water, which is a fancy way of saying what it's made up of. Water is always made up of 2 hydrogen atoms, 1 oxygen atom. Now, chemical composition is very important in chemistry. So we can show this chemical composition using a special name or a special abbreviation. And this is called the chemical formula. Okay? The chemical formula tells us which elements are in a compound, and it tells us how many atoms of each element we have. The chemical formula for water is H2O. And this formula tells us that in water, we have 2 hydrogen atoms and 1 oxygen atom. Let's decode this chemical formula and see how it tells us that information, okay? H, right here, is the symbol for hydrogen. And H with a 2 after it means 2 hydrogen atoms. And O here is the symbol for oxygen. And O with no number after it, right? We just have an O. We have no number after it. O with no number after it means 1 oxygen atom. If you only have a single atom, you don't write the number 1. You just put the element symbol, H2O. People always want to put a 1 after the element symbol when they just have 1 atom. They can't resist, but that is wrong. So here we have H2O1 crossed out to make this point. You don't use the 1. You just put the O. Putting the 1 is wrong. It's not like it makes it better. It's not like, oh, this is a little thing that I don't have to do, but adding the 1 makes it more perfect. No, adding the 1 makes it wrong. Don't use a 1 when you have just 1 atom. Anyway, H2O is the chemical formula for water, and it tells us that water has 2 hydrogen atoms and 1 oxygen atom. In chemistry, you usually use a compound's chemical formula much more than you use its name. So it's really important to get comfortable with chemical formulas and see how they work. We'll look at a few more examples. Here's another compound, hydrogen peroxide. Like water, hydrogen peroxide is also made of hydrogen and oxygen. But if you zoom in on a molecule of hydrogen peroxide, you see that it's made up a little bit differently. Each hydrogen peroxide molecule is made from 2 hydrogen atoms, HH, attached to 2 oxygen atoms, O and O. And every single hydrogen peroxide molecule in the world is made up of 2 hydrogen atoms and 2 oxygen atoms. That's its chemical composition. So, how do we write the chemical formula for hydrogen peroxide? There it is, H2O2. H2 means 2 hydrogen atoms, and O2 means 2 oxygen atoms. Now, water and hydrogen peroxide may seem pretty similar. They're both made of the same 2 elements, hydrogen and oxygen, but the number of atoms isn't the same. Hydrogen peroxide has 1 more oxygen atom than water does, and that makes all the difference. Water and hydrogen peroxide are very, very different. Water is about as safe as it gets, but if you drink hydrogen peroxide, it can be very poisonous. So, different chemical composition, different characteristics. Very, very important. Now that we've covered the basics, let's look at 2 more compounds. Here's natural gas, which is actually a compound called methane. Methane is made from the elements carbon and hydrogen. And methane is made of molecules that have 1 carbon atom, that's the black atom here, connected to 4 hydrogen atoms. You can see those here. So, What's the chemical formula for methane? It is CH4. One carbon atom, so we just have the letter C with no number after it, and 4 hydrogen atoms, H, the symbol for hydrogen, with a 4 after it, CH4. Once again, remember, if there's just one atom, you don't put the number 1. So you don't put 1 after C. No, that would be wrong. Don't do it. Here's our last compound, table sugar. Okay, table sugar is actually a compound called sucrose. And sucrose molecules, as you can see, are really big. They're made of a whole bunch of atoms all crammed together. Each molecule of sugar has 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms. They're all connected together as a group in a giant molecule. So, what is the chemical formula for sucrose that explains this chemical composition? It is C12, 12 carbon atoms, H22, 22 hydrogen atoms, and O11, 11 oxygen atoms. Okay, now that you know the basics of compounds and how to write chemical formulas, let's take a look at some TEAS practice problems. Here's our first one. The chemical formula for sulfuric acid is H2SO4. What are the elements that compose sulfuric acid? For a question like this, you've just got to know the element symbols in the formula H2SO4. That's why I'm always saying you just got to memorize the names and symbols for the common elements. There's just no way to get around it. Anyway, H is hydrogen, S stands for sulfur, and O is oxygen, and that matches choice C. The only tricky element here was sulfur, S. It's a common mistake to think that S stands for sodium, but sodium is actually Na. It's one of those tricky ones. So, know your basic elements and you'll breeze through questions like this. Here's another one. The compound potassium perchlorate has a formula containing 1 atom of potassium, 1 atom of chlorine, and 4 atoms of oxygen. What is its formula? Well, we'll start with the elements involved. We have potassium, that's K. Ooh, a tricky one. Chlorine, that's Cl. Also kind of tricky because a lot of people think it's C. It's Cl. And then oxygen, which is O. So we have 1 potassium atom, so we just do the K, no number after it. Next, 1 chlorine, Cl, no number after it. And finally, 4 oxygen atoms, so we do the O with a 4 after it. KClO4 matches choice D. Look at these other answer choices. They are ready to trap you in so many ways. A uses the number 1 because some people think to use it. Wrong. Don't let the TEAS trap you. And choice C is ready to trap you with this letter P. That trap is waiting for people who didn't remember that the symbol for potassium is K. Got to know these basic elements and you'll avoid the TEAS tricking you. One more. Monosodium phosphate is a common additive found in animal feed, toothpaste, and evaporated milk. It's a compound composed of 1 sodium atom, 2 hydrogen atoms, 1 phosphorus atom, and 4 oxygen atoms. What is its correct chemical formula? Here are the elements at play. We have sodium, Na, tricky one. We have hydrogen, H. We have phosphorus, P. Remember, phosphorus is P, it's not PO. Some people think it's PO, it's not, just P. And finally, we have, oxygen, O. Okay, so these are the elements that we are going to be using. Now, one by one, we have 1 sodium, so that's just Na. We have 2 hydrogen atoms, so that's H2. We have 1 phosphorus atom, just the P. No number. No number. And finally, we have 4 oxygen atoms, which means that our correct chemical formula is BNaH2PO4. And if you look at the answer choices here, there are plenty of traps. You'll see some elements with a number 1, which is wrong. You never use that. And you'll also see the letter S, because a lot of people think that S stands for sodium. Don't get tricked. Let's move on. Now, sometimes when you see a chemical formula, you'll see parentheses. You see these parentheses here? And there's some parentheses over here. Later on, we'll talk about why you would use parentheses. But for now, all you have to understand is that this number here, after the parentheses, multiplies everything inside the parentheses, just like in math. So let's look at barium hydroxide here on the left. We have an OH inside the parentheses, and then we have a 2 outside. That means we have 2 groups of OH, because there's a 2 outside the OH in parentheses. 2 groups of OH. Now, how many total atoms do we have? Well, each group of OH has 1 oxygen and 1 hydrogen. OH, no numbers there. But if we have a 2 outside those parentheses, that means that we have in total 2 oxygen and 2 hydrogen. Over here on the right, calcium nitrate, NO3. Then we have parentheses, and there's a 2 outside the NO3. So that means that for total, we have 2 groups of NO3. Now, each group has 1 N, 1 nitrogen, and 3 oxygens. Each group has 1 nitrogen and 3 oxygens. We have 2 of those groups, which means that we have in total 2 nitrogen and 6 oxygen. Let's look at how the TEAS might ask a question about chemical formulas with parentheses. The compound aluminum sulfate has the chemical formula Al2SO4 Which of the following shows the correct number of atoms in the formula? Ooh, in a question like this, the TEAS is asking, do you know how to read chemical formulas? And do you know how to use parentheses in chemical formulas? Okay, so let's break it down. We have Al2, and that number 2 tells us that there are going to be 2 aluminum atoms. Okay, that's important. Next, SO4 in parentheses with a 3 outside. Okay, that means that we have 3 groups of SO4. Each SO4 group has 1 sulfur and 4 oxygen atoms. 1 S, 4 O's. Okay? But we have 3 groups. We have 3 groups of the SO4. So that means that in total we have 3 sulfur and we have 12 oxygen. So altogether we have 2 aluminum, 3 sulfur, and 12 oxygen. Know how to use parentheses, and you'll be able to ace questions like this. Now, you might be wondering, should I have known that the name of that compound we just looked at was aluminum sulfate? The answer is no, absolutely not. The TEAS is rarely going to ask you to name compounds, but there are a few common formulas that the TEAS does expect you to know. They are these compounds and these formulas that we have on the list right here. Some of them might be familiar, okay, like carbon dioxide is CO2, oxygen gas is O2, water is H2O. But there are a couple that you might not know, like glucose or blood sugar, which is C6H12O6, ethanol, which is the type of alcohol that you drink, C2H5OH. You really need to memorize this list of names and formulas. There's just no getting around it, okay? It's like the way you have to memorize some of the basic elements on the periodic table. You should use flashcards to learn these chemical formulas because they're going to show up over and over and over again on the TEAS. And our final question here is an example of how this stuff might show up on the TEAS and an example of how knowing these is going to be really important. Which of the following substances can be dissolved in water in large quantities? Oof, select all that apply. I'm guessing that if you saw a question like this on the TEAS right now, you'd think you could never answer it. But I bet you could. Let me show you how to think through this. First, you do have to know some of the common chemical formulas for the TEAS. That's why I said you just got to memorize that list. There's no getting around it. So let's identify each of these chemical formulas. We've got carbon dioxide gas, glucose, blood sugar, sodium chloride, table salt, oxygen gas, and ethanol alcohol. So once we decode the chemical formulas, we figure out what they stand for, it turns out that these are all substances that you're actually pretty familiar with. Now for the TEAS, I often say, focus on what you know for sure. We're looking for the compounds that we can dissolve in water in large amounts. Think it through. Which of these can you really dissolve in water based on your own knowledge and your own experience? You know this. Well, you can always dissolve a lot of sugar in water. Okay, so that's B. You can also dissolve lots of salt in water. Choice C. And finally, if you've ever made a mixed drink, you know you can dissolve a lot of ethanol or drinking alcohol into water. You're probably not sure about carbon dioxide and oxygen gas, so leave those out. You know 3 of them are right. Choose those 3. Stick with what you know and trust it. And it turns out that only a tiny amount of carbon dioxide and oxygen can dissolve compared with these other 3 choices. So the correct answer here is B, C, and E. We got this right just by thinking it through step by step and memorizing that list of common chemical formulas. You got to do that. But you memorize that and then work through these problems step by step, focusing on what you know. That's how you're going to prevent the TEAS from tricking you. That's how you're going to ace it. Okay, so I hope you feel like you really learned something from this video. If this was helpful to you, go to TEASin1day.com to find more TEAS study materials like this, as well as my full Chemistry Essentials course that covers all of these topics. And if you have any questions, you got any comments, email me, Tyler@TEASin1day.com. I look forward to hearing from you. Best of luck studying for the TEAS and taking the TEAS. I hope you ace it.